this lecture we're going to learn what science is and what science is not. Science is a body of knowledge, right? It's basically we have all of these facts and different observations and all of the discoveries that we have about nature and our universe. And we really build upon the previous knowledge that others have already gained. And this is known as building upon the shoulders of giants. So for this course and also for our lives, scientific literacy is really important so that we can operate effectively in this world. Now, there are some words that are used in science that are sometimes misunderstood, and the first one is scientific hypothesis. Many times people think a hypothesis is simply just a guess, but it's actually more than that. It's an educated guess about processes in the physical world that are consistent with current understandings. Now, hypotheses must be testable. Think to yourself, what does that mean? It means that there is some observation that could prove the hypothesis false. Notice that we never prove anything true in science, rather we can only falsify in science. Now, another word that is sometimes confused is fact. And a fact is simply an observation that can be repeatedly confirmed over and over again. So you can measure, for example, the length of the forewing of this dragonfly, and maybe you say it's 42 millimeters long. Or you can go to Hawaii and take the temperature and say that it's 15 degrees Celsius. But what's interesting is that our observations are always gathered by our senses, which cannot be entrusted entirely. In fact, observations can change with better technologies or with better ways of looking at the world. For example, if I were to maybe measure now the forewing with a laser ruler, maybe the actual length with the laser ruler is 52.001 millimeters. And so therefore, this fact now becomes obsolete. So it's ironic that in science, actually, facts are more susceptible to change and to being shown not to be true than theories are. So this brings us to the word of theory. Theory provides this broad understanding of the dynamic processes in nature, and they're supported by large amounts of evidence accumulated from different sources. I love this quote where it says, "In science, theories do not turn into facts through the accumulation of evidence. Rather, theories are the endpoints of science." I also like to think of it this way. Okay, so here's a theory. What goes into a theory? Well, observations, facts, predictions, tested hypotheses, laws, and every other thing that you can basically think of in science goes into a theory. So another quote that I really like that summarizes this is that theories are the crown of science, for in them our understanding of the world is expressed. The function of theories is to explain. In kind of my dumbed down language, I would say theories are as good as it gets. There is nothing better than a theory in science. So science then, as a way of knowing, has to always be used to explain the natural world. Science cannot touch or explain the supernatural. And this is because science, once again, is testable against only the empirical world. Now, we do gain lots of knowledge. But regardless, all of that knowledge still remains tentative because we never prove anything true. We can only prove things false in science. It is only falsifiable. So we never say for sure that something is true. What we can say is that we are very confident that this is the correct answer and this is the way that this system works. Now, knowledge then in science must come to the point where it becomes scientific consensus, and that's when it becomes a very strong idea in science. And the only way that this happens is that claim, so someone has an idea, they've tested it, they've done made observations, they've done lots of those two types of initial scientific endeavors, but then it must be subjected to critique. And this is done by peer review. Once knowledge claims have made it through peer review, then they can become scientific consensus. Or if the other peers decide this is not a good idea and they can maybe do other experiments to show that the idea is not a good idea, then it can be rejected. So good ideas are kept and bad ideas are rejected. And that's the way science works. It's continually getting rid of bad ideas and continually supporting good ideas.
Hi, this is Dr. Ogden. Just going to interject here. Of course, now I'm bearded and it's many years later since I made this video. But I thought it would be interesting to just talk quickly about an example that has to do with this idea of getting rid of bad ideas and keeping the good ideas. And the example that comes to mind is wearing masks in the time of COVID. Initially, there wasn't a lot of push to wear masks, at least here in the United States. And even some of the officials in the government were kind of like, well, maybe we shouldn't wear masks, but it wasn't clear, and the WHO wasn't clear on this either. But fairly quickly, as studies started to come out and as science started to weigh in on this subject, the wearing of masks for the COVID disease became a recommendation that more and more evidence started to build. So the question sometimes that I hear is, well, are they wrong, or who do you believe? It's so hard to know who to believe. And I think that what we miss here is that the fact that as new evidence unfolds, it causes science and medical experts to shift their position. That is a positive attribute, not a negative attribute. It's something that we should actually be glad to listen to and not denigrate. And now, if I'm recording this in July, near the end of July, and basically the science has converged on the idea that mask wearing during COVID is going to help, because they've done all of these studies where they look at the droplets and the aerosols that are coming out of an infected person, and the masks do inhibit that. And then you get a little bit of protection too just by wearing the mask for yourself, but it's mostly to protect others. And the science on this now is pretty much decided. And even the White House finally agreed to this as well, that this is a good thing to do. And so this is the nature of science. When a new idea comes out, there might not be a lot of evidence to know which way you're supposed to go. You try to rely on what you've learned before. And in this case of coronavirus, most other coronaviruses infect the person and they quickly start to show symptoms. And so it's not that important maybe to mask someone as it is once you're sick, then you just stay at home, right, to not infect others. But the idea that this coronavirus infects people and they stay asymptomatic, and some people asymptomatic for the entire time that they have the virus and they're shedding the virus particles. So it's important that science came to bear on this, and that as the studies came in, the ideas start to converge, and then it was throwing out the bad ideas and keeping the good ideas until you have one clear consensus, and that then becomes a very reliable recommendation that we can all try to follow. So I thought I would just interject real quick, because that seemed like a timely example of how science deals with this, with a very messy world. I mean, biology is messy, and so trying to deal with all of this messiness is difficult, but science is up to task. And as a community of scientists, they all try to come and find out what is the best answer. Let me just also say one quick thing about this, because perhaps you're listening to this and already you're going, oh, well, that was all driven by politics. Science is apolitical. At its purest form, it is apolitical, it is unbiased. The problem, perhaps, is that we have scientists, which are humans, and all humans have biases. We all do. And perhaps all humans have, a lean politically as well. However, I would argue that scientists try their hardest to not allow those biases and those leanings to come to bear when they're doing science. And I argue that science, for the most part, is an apolitical, unbiased process. And so as more and more studies come to bear, it converges on the best answer. The bad ideas are discarded and the best ideas are kept. And if someone thinks that there's this conspiracy that's going on, then do the evidence, do the work, and present your idea. I mean, if someone could somehow present evidence that the earth was actually flat, do you imagine how popular that person would be? And what an amazing discovery in science that would be. But of course, that's not going to happen because the majority of the science already has shown and has converged on the idea that the earth is round. Okay? But that would be the same for mask wearing. If there really was a really good lot of studies that were showing that mask wearing didn't make a difference, that would overturn the science that is there. So I know that this may sound a little controversial. I don't want to really get it that way, but I wanted to use this as a really good example about how science proceeds. So you should continually have a very critical mind. It is not wrong to be critical of ideas and to critically think about those ideas. But it is also not correct to just discard something because you think that it may be biased. We should be honest enough to look at the evidence. And if we are wrong and the evidence is pointing in a different direction, we need to be humble and change our minds. And in my view, that's what happened with mask wearing. The evidence came to bear and everyone saw the writing on the wall and said, yep, this is going to help in this situation. So anyway, there's my interjection, and I hope you like my beard.
So science is not a democracy. Science does not come from the revelation. The only authority in science is the empirical world. There's no unexplained exceptions, no value judgments, doesn't rely on faith, and there's no accepted tradition. Science looks at ideas, and if they're good, they are kept, and if they are not, they are thrown out. Now, there are other ways of knowing. For example, many people can accept the fact that they can gain knowledge through authority. Like in my household, I have certain rules. My kids know you don't do this. And that may be different in someone else's house, but in my house, that is the knowledge. Many people belong to religious organizations or political organizations or whatever, and there may be knowledge that can gain through an authoritative figure. Democracy sometimes decides on knowledge. For example, how fast you can drive your car down the road. Consensus. Sometimes knowledge is decided upon by everyone agreeing upon a decision. Many people rely or believe in the fact that revelation or inspiration can provide knowledge. I love art and I love music, and I love to be able to go to a museum and just stare at art paintings and sculptures, and I really think you can gain insights from doing that. And so I think many people would argue that there is knowledge that we can gain aesthetically, or even morally. There's knowledge that we can gain, and ethical knowledge as well. The point is, there's lots of different ways of gaining knowledge. Science does not have a monopoly on knowledge, so therefore science is limited in its power. Now, even though it is limited, it is still very powerful, especially at explaining the natural world. So many people ask, well, can these separate ways of acquiring knowledge coexist? I may differ with some colleagues on this, but I think so. I think that one can gain knowledge in art and one can gain knowledge in science. So science is definitely then a way of knowing. And in science we can ask questions about the natural world. So what science, though, cannot do is try to assign meaning to these things, or make decisions about morality, or explain God, or tell you what to do with your life. These are the types of areas where you would want to go to the other ways of gaining knowledge to make decisions.